are you doing that? What is going on with you? Why are you doing that? Oh, I love it. Computer, what are you doing, buddy? Okay. All right, computer, what are you doing? There we go. Okay. Oh. If it's not the Wi-Fi messing up, it's the computer itself. It's got to be something. So it looks like I'm okay now. All right. Good morning, everybody. Anybody have questions? All right. While you guys think about that, I just added in for section 1.1. Remember, I have the copies of the homework up here for 1.1 and 1.2. If you look at the bottom, I've added in the other part of the homework, right? The prep skills questions. Because remember, for homework, you've got the main page. Come on, homework. Right, you got the main page, and then you got the other page, which is the prep skills questions. So I'll get the one up for 1.3 and 1.4 after class, if I remember. Hopefully everybody's got a book or have one coming soon, right? Okay. So any questions from the homework that everybody has started working on? Any questions? Baha says good morning to everybody. Are you guys okay out there? What's happening?
Because not say anyone good morning.
Morning.
Good morning.
All right. So if there's good morning. If there's no specific questions, I want to go over how to construct a bar graph. And then I'll see if anybody has questions after that. And then if not, we'll just.
Yeah, it's now clear. Good.
Oh, okay, good. We'll just keep going if that's we'll see. All right. We talked about pie charts. We talked about how to construct pie charts. And if you haven't given it a try yet, you got to try it. So you got some questions to ask me. One thing to remember is at the end of the work for a pie chart, the whole thing better be filled in, right? With pie pieces, or else something went wrong. You got to win that Trivial Pursuit game. You got to fill in all the pie pieces. All right. I don't know if anybody got that reference. It's all right. All right. Now, let's talk about bar graphs. Let's see. Let's say we look at class grades. And so we have A's, B's, C's, D's, and F's, right? Why do I have to use all the board, Jeff? I need some room. All right, you put it over here. Oh, oops. So let's say that 12% have an A. What do you got, Jeff? 32% have a B, 35% have a C. Where am I at now? I'm being careful about something. 10% have a D and 2% have an F. Right? This would be pretty decent. What did I have to be careful about as I made this up? What should happen with this data?
They should all get, should they get close, they should be fully 100 because you're not rounding this data, right?
Yeah. And this one, I'm not really rounding. This one, I had 100 people in this large class. So I didn't need to round. But it should add up to close to 100. In this case, it actually adds up exactly to 100. So what kind of graph could I use to do this data?
You could use a pie chart.
I could use a pie chart or a bar graph, to be honest. But if I used a pie chart, just really quickly, do you remember how all right, I'm going to do this anyway. I wasn't going to do a pie chart, but I might as well because I think everybody probably has questions.
The total is 91.
Say again, sorry. Did I not do that right? Let me see.
Isn't 100?
78. 78, 80, 90. Okay, so let's make, unfortunately, there's 12. So thank you. My early morning math is lacking. So I was off. 67. Yeah, in my head, I made that 88. That's 78, 88. Now it's 100%, right? Okay, cool. That's why I asked your help to check my work. All right, now, how many total?
101, I think.
Sorry, yeah, it is 101. Come on, Jeff, you could do better. What am I doing? Oh, I see. I'm silly. All right. Beautiful. So we're helping each other out. Now, how many total degrees are in the circle?
360.
360. So you could do this any way you want to. I could do it sort of like the book. I think the book sort of does it this way. It really, really doesn't matter, right? I would put down these halfway marks for myself. Let's see if I can do this math correctly. Okay. You guys with me? So that's what I would give myself to work with. Now, how many degrees should the A pie piece be? How do I figure that out? What percentage of the circle should the A's take up?
If it's not a trick question, 12.
It's definitely not a trick question. No.
12%.
12%. I love it. All right. And there's 360 total degrees here, right? There's 360. If I keep going, there's 0, and then I go around 360. So there should be 12% of the circle. 12% of 360 should be the A pie piece.
30 degrees.
Yeah. So if I do 12%, 0.12, right?
Yep.
Bam, bam. Because percent means divided by 100. And if you divide by 100, you move once, twice back. Everybody cool with that? Converting percent. Okay. I was worried because I don't really speak baby too well. All right. So 12% of 360. Of means times. So 12% of the circle should be made up of the A's, the A pie piece. So somebody help me out. What was 12% of 360?
44?
44?
Yeah, it should be 43.2, so we can do 44 or 42 or 43.
No, you have to do 43. So actually round it. I like it. And to be honest, it doesn't have to be that perfect. But do you guys, and again, you could do the degrees like I did. I started at 0 here, and then I went around this way. It really doesn't matter. I'm just chopping the circle up. So it really doesn't matter how you put these down. But I want to go from 0 to 43. That would be my A's. And this, of course, is the center, right? So that's the chop for the A's. That's the pie piece for the A's. So I ended up at 43 here. Are you guys with me? How big should the next pie piece be? How big should the B be? How big is the B?
Okay.
32% of 360. And what is it? I'm sorry?
Yes. 150.
150?
15.
15? No. Oh, 115.
Yes.
Okay, thank you. All right. Let me stop for a minute. Does anyone not see where something came from? Let me get rid of this. Let me do this better. All right. Is there anything up here that you don't see where it came from? Yeah, so this is approximately, right? So we round it. I like it. Is anybody not with me on this? Let me know right now. Again, the math here isn't difficult. It's just different math than we're used to. So the next pi piece for the b's has to be this many degrees. So what's wrong if I just go to 115 and I put a line there and say that's the b piece?
That's incorrect.
Sorry?
You have to add the 40. That's incorrect. You have to add the 45 degrees.
I love it. Well, I'm at 43. So if I start at 43 degrees and I have to add on there 115, where am I going to end up? What's 43 plus 115?
148.
So the B piece, the piece that's for the B has to be 115 degrees by itself. So the A piece stopped at 43. So the B piece stops at 158, which is about right here, maybe. And then you just keep going. You do the C's, right? Might as well finish this out. You got to speak up if something's not making sense. You just keep doing the same thing over and over until you go crazy, and hopefully you get done before you go crazy. For the C's, it would be 35% of 360. That's the chunk that will be the C's. What's 35% of 360?
126.
126. That sounds right. I think it's exactly that, right?
Yes.
So I can just kind of keep going here. I stopped at 158. I want this one to go 126 more. So now I got to go to 284, right?
Yes.
Okay, so now this next piece has got to go through a degrees of 126, but I'm starting at 158. So where's 284? It's about right here, maybe. Shwoop. So this will be my C's. Now this visually is making sense, right? Well,
Yes.
might be a
kind
little
of.
off, but C looks like it's probably the biggest. B is really close behind. A is definitely the smallest. And now I do the same thing, 10% of 360, that's easy. That's 36 degrees. Right, where did I end up here? 284. So now I go 36 more degrees for my D's, and I go, you can do that, Jeff. I don't trust myself this morning.
40.
40,
Yeah, this is
39 point,
39.6.
39.6, yeah, so about 40 degrees. I like it, right? So then I would go, and this is getting a little, and here I can have a little, I don't know if you guys are with me or not. Aren't these about the same size?
Yeah.
This one's like a little bit bigger.
Yeah.
I can sort of cut this in half a little bit. So maybe even right there. Well, that's a horrible line, Jeff. So this would be the D's and this would be the F's. So it doesn't have to end up perfect, right? You actually, but I do want to see this work because this is getting you guys used to how to do a percentage of a total. I like it. And my picture could have been a little bit better. I don't have the center quite in the right place, but if you gave me this with this work, I would be over the moon. It would be awesome. Okay. Now, so that's a pie chart. That's how to do a pie chart. Let's look at a bar graph. Okay. Let me know if it's okay. I'm going to erase this. Anybody? Oh, okay. Okay, here we go. So now if I ask people, what do you got, Jeff? I don't know. Which cars do you like? All right, so I have BMW, I have Hyundai, I have Ford, and I have Chevy. Let's just keep it straightforward, right? So now maybe 38% say BMW, 21% say Hyundai, 57% say Ford, and 42% say Chevy. Is anybody concerned with what's happening up here?
No.
Yeah, is
You
everybody
may need
okay
a
with?
bar graph.
Yeah, for a bar graph, they don't have to add up to be 100, right?
Yeah.
And they don't have to. They don't add up to 100 because somebody could have said, "I like Fords and Hyundais." Okay, I like it. Maybe is everybody with me? So I cannot make a pie chart out of this, but I can make a bar graph. Bar graphs are so freaking awesome. The only thing you have to worry about whenever you make a graph or a number line, the scale you use has to be consistent. So I get too many people that do this kind of thing, 21, 38, 42, 57. That doesn't make any sense. Do you see how this is 4? And this is 15? No, so don't, no, get out of here. Get out of here, get out of here. All right, let's try this again. So if I need to make it up to 57, can somebody tell me what kind of scale I might want to use?
20s.
Tens.
Yeah, let's use 10s. 10, 20, 30, 40, and I'm just going to have to add one more. Boop. Okay. And so now I got my BMWs, my Hyundais, my Ford, my Chevy, and I just make a bar. How tall is a bar is exactly this. So I go up to 38. I go up to 21, right? I go up to 57. Woo-ha! And then I go up to 42. Done. Oh, so much better than pie chart, right? No? Okay. The most important thing on this, and the hardest thing for some students, is this has got to be consistent. The scale has to be consistent, or else you're lying to people, right? Okay. There's a bar graph that was horizontal. It could be horizontal or vertical, but more often it is this way. It's vertical, right? But again, in real life, they do them horizontally sometimes. If you want to, you can, but you don't have to. Somebody just asked me a private chat message. In the book, they have some that go, the bars are laying down. So you could do that. It's just this is done more often. Where am I pointing? There it is. Okay. How's everybody so far? You guys doing okay? Any questions? Did anybody think of any homework questions? Anything left over from the review stuff?
I have a couple, Professor.
Yes.
I'm not sure if you did it during last class session, but 1333 was one of my questions.
All right, let me see.
Actually, I have a couple.
13. You're fine. Here we go. 13. Oh, all right. All right. So this was this problem here. Let me just show it, and then we'll do a problem like it. This here problem, right? The negative 5.8.
Yes, sir.
All right. So, tell me this: do you want to pass this class, or do you want your calculator to pass this class?
I want to pass it.
Yeah, your calculator can pass a class and go have a nice life and meet another calculator, have a little calculator family.
Oh yeah.
And you're stuck taking the class over. So I'm not going to make you use a calculator on everything, but especially on these first few things. Well, on this first thing, I want to see what you can do, not what can your calculator do. So, my first question before we get into the decimal-ishness of this, can somebody just tell me what this is?
-17.
Yeah, so you basically do this, right? You do this, and you throw a negative on it. That's how you do same sign numbers. You add them and put the sign back on. So if I said, what is -11.7 plus -4.5, you would do 11.7, 4.5, add them up, right? So 2, 1, 6, 1.
Oh, okay.
And then what would the answer be? Don't put this.
You have to round it?
No. What was the answer up here?
Negative.
17.
Negative.
Oh,
Negative, yeah. Right, I owe 1170, I owe 450, so I owe 1620 total. So it's got to still be negative. So that's how you do that by hand.
okay, there we go.
Now, to me, the harder question would be something like this. How would you do this weird shit here? So this is, let's see. Sorry, is there a little one? I got to be careful with my language. What if I had -32.9 plus 11 point, that doesn't matter, Jeff. 11.8. How the hell are you supposed to do that? So when the signs are different. So somebody over here, what is -11 plus 2?
-9.
Yeah, so when the signs are different, subtract them. 11 minus 2 is 9, and put the sign of the bigger one on it. Visually, real quick, let me give you a visual. If you were 11 foot down in a hole and you climbed 2 feet up, how far down are you now? 9 foot down. If you owed somebody $11 and you found $2 and you give it to them, you still owe them $9. I mean, so there are physical representations of this work. All right, I like it. So what do I do here then? They are different signs. So I subtract them. Right, this is not too bad. But then what's the answer going to be? Is it 21.1?
Negative.
Because the bigger one is negative. Oops. Because I got negative this, and then I add some positive. It's still negative, but it's not as negative. It's gone up a little bit. It's sort of like if it was negative 32.9 degrees, and it goes up by 11.8. Now it's only negative 21.1 degrees. Ooh, let's go hiking. No. All right. Maybe? Is that cool, everybody?
Professor, I have the same one, but minus 11.7 plus bracket times minus 4.5. I use the time here, plus times minus. In this case, is a minus. That's why I say minus 11.7 minus 4.5 and give me the same total. Look like I take out the bracket first. Look like I use the times here because plus times minus.
Wait. There's no times here, right? Are you talking about a different problem?
No, when we see a bracket, that's mean we times.
No.
The sign.
Nope.
No.
When you see two things sitting next to each other, that means times, right?
Okay, but here is not the plus, it's times.
If I see this,
yeah,
that still means subtract. Right?
No.
It's not 7 times 2 for sure.
No, it's not 7. The minus times the minus.
All right, wait a minute. I really want to understand. This problem has no multiplication in it, correct?
Yeah, because the plus and minus is not, we can't put it together. That's why we supposed to separate it. And if we use the plus times minus, that's mean minus. And
Okay, so then you
give
get
me
negative
the
11,
same
no, hold
result.
on, stop. Then you get negative 11.7 minus 4.5. These mean the same thing. Neither one has multiplication.
Okay, that's why we take out the plus, because the plus times minus is minus.
Okay, sure. I love it, yeah. I was just writing it the way the book had it, but you're right. We don't need a plus and a minus. We could just write a minus.
Yeah,
They mean the same thing. And
But
so
it's
you would
not
do it the
means-
same way.
but
Yeah.
it's not means times because we see the bracket because.
No.
Doesn't
So
matter, but-
listen. Stop. Are there numbers sitting directly next to each other?
Mm.
Or are there operations in between them? Right? So if two numbers are sitting next to each other, do you see that?
Yes.
That
That's
is
mean
time.
minus 4 times. Okay,
That is
What-
times.
yes,
That is times.
yes,
This, is that times? No.
yes. Because now, in my opinion, sorry, maybe I'm wrong. Minus times minus, that's mean a plus.
I
Minus
love it.
4 plus 3.
Yes. Is that times? No.
No, I mean, when I see the bracket, I use it as a times. That's why minus times minus.
Yes.
Plus.
But you're not multiplying the numbers. I really.
No,
right.
it's not the numbers, only the signs.
Okay, so we're good. I agree with you. Positive times negative is minus. There's no multiplication in that problem.
Yeah.
Okay, because earlier I asked you if there's multiplication here. You said yes, and I was concerned.
No.
Okay.
Okay.
You would do this problem the same way because it's the same problem. Are they the same sign? Yes. So you add them and put the sign back on.
Okay, thank you.
You're welcome. Please, what? Tame it? Oh, somebody still wants me to be careful of my language. Again, you've chosen poorly in that respect. I'll do what I can. This is college, everybody. You're gonna have to deal with that shit sometimes. So, okay, so that's it for that. Anything else? Did I miss anything from chat? Let me see. 1317, there we go. Did I miss anybody else? Okay, good. 1317. What do you say? Oh, okay. We talked about this one. I'm not even gonna write it down. Don't even write this down. What is 2 less than 8?
6.
Does everybody agree?
Yes.
Anybody feel differently? It's okay if you do. Maybe he's wrong. So of course that's right. 2 less than 8. But what math did we do? If I say 2 less than 8, how would you write that math? What did you actually do?
8 minus 6.
8 minus.
I mean 2. Sorry, I was thinking about something else.
No, I'm with you. You think about the answer got in the way. I'm with you. So if I say 20 less than -7, what do I write first? 20 less than -7. So 2 less than 8.
-7.
Negative
Negative
7
7.
minus
Minus 1.
negative 20.
No.
Minus.
Minus 20.
There's no -20. So -7 minus 20. So think about it. If you're at -7 and you go 20 less than that, if it's -7 degrees and it goes 20 less than that, isn't it going to be even more negative? And that's exactly what's going to happen here, right? Both the same sign, so you add them and put the sign back on. Is that cool? So that's number 1317. I basically just did it for you, but sometimes I can't stop myself. All right. Anything else, guys? Any other homework questions? 1343. This first homework assignment makes me feel like I'm a history teacher. Teacher, what happened in 1343? All right. So yeah, all right. So if I said 2 3/4 hours, how many minutes is that? Right, we'll do a problem like this. 2 3/4 hours. Well, 2 hours, how do you figure out how many minutes that is?
120.
Yeah, 2 hours times 60 minutes every hour, 120 minutes. What about 3/4 hours? You do the exact same thing.
Yes.
3/4 of an hour, of means times. 4 goes into 16, 15
45.
times. 15 times 3 is 45. So how many total minutes is this?
165.
265.
I see.
Is that cool? Yeah, so that's how you handle fractional hours. 2/3 of an hour is 2/3 times 60, because of means multiply, in an hour is 60 minutes. I like it. Isn't this like a quarter of an hour before 3 hours? Isn't a quarter of an hour 15 minutes? Isn't 3 hours 180 minutes? So 15 minutes before 180 is 165. There's another way you can do this, right? If that other way didn't make any sense, then don't do it that way. Do it this way. So that's how you do 1343.
Solid. Thank you.
You're welcome. Okay, so I think that's it. Let's get back into, so we finished section 1.1. We're going to get into section 1.2 because that kind of makes sense. Let me see. Here we go. All right, so for those of you who don't have your book yet, we're going to be doing these problems here. Oops, shit. Right, so if you do have your book, this is page 23. Let me see if it's the same as the physical book. Yes, so it's on the bottom of page 23 if you have your book, and then it goes on to the next page, right? So I'm going to keep this up on the screen. If you don't have your book yet, just kind of write those down real quick and I'll go to the next screen. See if we can do these. I'm going to want you to try these out and then we're going to do them together. So if you're going to make mistakes, now's the time to do it because I'm not grading anything. All right. So everybody got those copied, those 4 problems there? And again, if you have a book, go ahead and open that bad boy up. Page 23. All right, let me see. I'm going to go to the next page. Go ahead and start working on these problems if you already have your book. All right, here comes the next page. So through 10 there. So through 10. Go ahead and copy those bad boys down and then just start working on them. If you have trouble, don't worry. We're going to talk about it. I want to see how much you can do. All right. And Aman, you can't get help. No help from anybody.
It's too hard for him.
Oh, okay. Okay. Well,
Yeah.
you never know. Don't worry, we will focus on fractions a little bit. So do what you can. If you have trouble with fractions, we'll talk about those a little bit more. So hopefully you guys see the main idea here is like terms. But sometimes when you don't have like terms, you can make them like terms, like we did up here with there was hours and minutes, but we can make them like terms. You can't always do that though. Okay. Oh, Aman, what's up?
Yes, are there examples of these in the book, please, Professor? I have not yet the book, but just ask about this one.
I'm sorry, which one?
Are there examples of these in the book?
Yes, there are.
Okay.
Yeah.
Okay, to show, just to know how we can do it. I mean,
Yes, there are. And also I'm going to talk about it right
okay.
now.
Thank you.
Okay, let me move you guys over here. I'm going to move the book over there. Okay. Let me share it again. If you didn't quite get done, don't worry. We're going to talk about it right now. So number one, is that a situation where you're able to combine the quantities? Quantities.
Yes.
Yes.
Yes, because they're both referencing the same idea. So they are like terms. So then I get a total of course, 17 grams of cholesterol. Okay. So far, it shouldn't be too bad. What about, all right, now look at number two. Now, I had some people doing some of these kind of problems wrong. Let me do something up here. Let me do something up here. Here we go. You ready? Can somebody tell me what is 3x plus 7x?
10x.
10x. What is 3 cars plus 7 cars?
10 cars.
10 cars.
10 cars. Holy shit. What is, excuse my language, holy shite, holy macaroni. There it is. What is 3 3 whales plus 7 whales?
10 whales.
Oh my gosh. So now watch this. Here's the thing I really want. So it's the same idea. What is 3 11ths plus 7 11ths?
10 11.
10 11ths. You are just collecting how many 11ths. So in this first thing, there's 3 11ths. And if I add 7 11ths, I of course end up with 10 11ths. Do not tell me you get 10 22nds. I'm like, I don't see any 22s, right? I don't see any over 22s. How do you get 10 of them? That is not correct. You don't add the denominators. And that explains why these have to be the same. You have to get a like denominator before you can add them, because otherwise they're not like terms. Does that help anybody? I mean, there's so much misunderstanding about denominators and fractions. The numerator is how many, and the denominator is of what. So it's just like 3 of these, 3 of these. It's the same idea. So we'll see another fraction problem here in a minute. What's wrong with number 3?
You have to
We can't
convert
count
your-
Not
together.
like terms.
Not like terms, but it is like idea, right? So here's where, since they're not variables, they're units of measurement, I can force them to be like, right? Did anyone remember how to convert stuff in this
So
case?
1 yard equals 3 feet.
Yes. So 8 yards would be 8 times 3 feet. Where am I getting that from? There we go. Is everybody cool with that? Every yard is 3 feet. So 8 yards would be 8 times 3. 24. Now I can do it. 24 feet plus 2 feet is 26 feet. Yay!
Professor?
Yes.
But since there are 2 terms, when we give an answer like that, do we have to give it also in yards? So, or do we only transfer it to 1 term?
Yeah. If the instructions don't specifically say,
Okay.
then you could actually do it either way.
All right. Thank you.
And to be really honest, you can make both of them into inches if you want to be crazy, but right, I wouldn't do that though. Might as well just work with one of them instead of both, right? So if the instructions don't say, you have a little bit of leeway. Hey, that rhymed. I'm a poet and didn't realize it. All right. What about, is everybody cool with number 3? What about number 4? What's going on there?
They're not like terms at all.
Yeah, not like in any way. So too bad, not like. So can't be done. For those that can't be done, explain why. Because one is measuring sodium and one is measuring carbs. Okay. Now somebody could argue, oh boy, somebody could argue, you could say, well, I got 27 grams of stuff. But the idea here is they're not like, you can't really consolidate, right? Like I could, number 1, it was easy. Number 1, I could consolidate all day. If I could just draw a circle, everybody would be happy. Okay.
We
Now-
can see only the math. is 10 and 17. We say 27 of grams of sodium and carbs. And
No, because that doesn't really communicate how much of each, you know, there's no
Yeah.
point to that, you know, so that's what I was saying. Somebody could argue that you could say you got 27 grams of something, but fundamentally they're not like terms. Okay, maybe. All right, I'm going to clear this. Everybody ready? I'm going to clear all my scratches away. All right, here we go. It is gone. Okay. Next page. What about number 5? This for some reason gives people trouble, but this is something we deal with every day, right? What's $5 plus 75 cents? You wish it was 80 bucks.
5.7.
Say it again.
5.7.
5.75,
75.
right?
and say 575 cents.
Or 575 cents. So here's what's happening in the background. 75 cents. How many dollars is that?
3/4.
3/4, or otherwise known as $0.75. 75 cents. If you divide it by 100, it tells me how many dollars that is, because it takes 100 cents to make a dollar. So that's $0.75. And then I could add it to $5 and get my 575. Or somebody said, okay, $5 times 100 is 500 cents. So then I could add 575 and get 575 cents. I would accept either answer because it didn't tell you which way to do it. Now, which answer is more everyday correct? This one, of course, right? Do we all walk around saying, that's going to cost me 2,847 cents? You're like, whoa, who are you? What? Bad alien. You're not pretending to be human well. All right. But I mean, technically I would accept either answer because both of them are correct. All right. How is everybody out there? You guys doing okay out there? Let me tell you a little story about money. Has anyone ever driven down the hill, Fletcher Parkway? You know that bowling alley that's right there? Do you guys know in El Cajon? Anybody know the bowling alley? And it doesn't really matter if you don't. I think the last time I went by, they still had this on the thing. They said 0.9, and this is before the pandemic, I think, 0.99 cents per game or something like that.
Yeah, it's like it's like their midnight deal or something. You go bowling at night.
No. Do you guys understand what this means? This should cost me less than a penny per game. 0.99 cents is not even a full penny. What did they mean? They meant this. And every now and again, I get it in my head that I'm like, I'm going to be that asshole. I'm going to walk in there. No, I'm not. Because I know what they mean. But my goodness, that's advertising. That is something, if somebody was a bigger dork than me, they could make a big stink out of that. So here's a penny. You somehow owe me change for my penny, right? Are you guys understanding what's happening? 0.99 cents is less than a penny. So they meant $0.99, which is 1 penny less than a buck. Okay, I like it. So look out for these things. Don't be an asshole, but still, just if you open a business, be careful about what you put on your billboard. Let me see what time it is. Okay. Number 6 should be easy. Yes? No?
Yes.
13.
13. X. I like it because they're like terms. No worries. You're just consolidating. I got 8 X's over there and 5 X's. They got 13 X's. Just 13 X's. What's wrong with number 7?
You got to make 2/5. Don't you multiply it by 4 to make it
Good.
20th?
So the idea is I currently have a problem that says something like 2 of something plus 7 of something else.
You got to Get a common denominator.
That's right. So I can very easily make 5 become 20. So then the denominators are the same. So like you guys said, I would multiply this by 4. Why do I have to do it on the top and the bottom? Let me pull this out by itself. So I
Because,
take 2 this. Go ahead.
I just said because, I don't know, it just
Oh,
seems
okay.
like
You ready?
You have to multiply the whole.
What is 4 divided by 4?
1.
So really, I am multiplying 2/5 times 1. Is there ever any time I'm not allowed to do that? I can multiply anything in the whole universe by 1 anytime I want to. So nah. So effectively, I'm not changing the number. I'm just changing the way it looks. So I get 8/20ths, correct? Somebody in your calculator, what is 8 divided by 20?
0.4.
0.4. What is 2 divided by 5?
0.4.
Okay, so the same number. So math says whatever human, it's the same number. Whatever you want to multiply by 1, I don't give a shit. But we're like, what I've effectively done, I didn't do a damn thing except I made them look different. Now I can do it. Now I've got 8/20ths plus 7/20ths. What do I get there? Eight 20ths plus 7/20ths.
15, 20, 15,
15.
20, then 1/5.
Wait a minute. All right. And I'm not sure what you just said. Wait, somebody's telling me. There, that looks better. So be careful. How do I reduce this?
Then divide it by 3.
You can't do 1/5. I think you're subtracting. You can't subtract top and bottom, but you can divide. Yeah, they're 3. Divide top and bottom, right?
Yeah. Fine.
Yep.
How are you guys with that? Is that okay?
Yeah.
All right. Here, I think when we get done with this, I'm going to show you something to do when the bottoms are not this nice. And then we'll probably call it a day after that. Let's see. So what about number 8?
125
They're the same
hours.
concept.
5 times
Just not like
0.4 because
120.5?
5
I'm not
times
sure.
24 plus
Yes.
5.
So I have days and I have hours. So let's convert days to hours. It's always easier to convert bigger units to smaller units. There we go. I like it. So 5 days and every day is 24 hours.
120 plus 5.
I like it. 120 plus 5, 125 hours. Now, technically, you could make both of them minutes, but why would you do that? You just need them both to match. So you do it
Okay.
the easiest way you can. Go ahead.
Can we say 120.5?
Definitely not. That would be a completely different. So one is it 0.5 hours or is it 5 hours?
0.5 hours.
No. What's it say? What's that?
120.5.
Oh, tell me. Look at the problem. Does the problem say 0.5 hours or does it say 5 hours?
5 hours.
It says 5 hours, not 0.5.
Yeah.
So 120 plus 5 is 125, and that's it.
It's okay.
There's not another way. So if this was half an hour, then I would agree, but it isn't. It's 5 full hours. So 120 plus 5 is 125.
Mm-hmm.
There's no half an hour in there, right? Okay. So 9 and 10 should be quick. What about 9?
9 has no like terms.
Good.
Not bad.
Why?
So you could do, what's 3y plus 2y?
5y.
Are you cool with that, Baha? Right?
5y.
Is that cool?
Yeah.
All right. What's 3y squared plus 2y squared?
I like.
5y squared.
5y squared, right?
5y squared.
But if I have 3 of these plus 2 of those, no, I can't do that. I don't have anything that's the same.
Mhm.
I can't consolidate, right? So to be like terms, they have to be the same letter and the same amount of each letter. So that one's got 2 y's and this one's only got 1 y. So they're not like terms. Oh, what do we got here? We switched them around. Oh, I see. Not necessarily. Yeah, it's okay if you switch them around. It doesn't matter. But somebody's asking, what if I wrote it like this? I like it because you're right. Normally we put them in descending order, but it really doesn't matter, to be honest. It's just a convention.
No like terms 2?
Say again?
No like terms 2, 7y by 2 plus 3y.
Yeah, this has got 7y squares. Now let me ask you. All right, here's the right way to look at this. Let me erase some of this stuff I got up here. All right, I see 7y squares, right? Do you see 7y squares in the problem? Yes. Do you see any more y squares? I see 7y squares right there. Do you see any more y squares to go with that? No. I see 3 y's. Do you see any more y's?
Uh-huh.
Nope. So there are no like terms. I cannot combine those.
Okay.
Okay. What about number 10? This should be nice, quick.
0.9.
0.9.
Done. All right. That should not be an issue, right? I like it. I like it. So here's something I want to show you about fractions. Let me see. I don't have a lot of space here. So what if my denominators were more disgusting like this here, let's say. Now what are you going to do, Jeff? Let's do, what is that? Sure. All right. Yeah, let's do that one. That's pretty gross. Ooh, look at that. All right. I want to show you a method that you don't have to use if you don't want to, but I'm just going to show it to you. This is kind of nifty. Do you agree with me that bottoms there are a little gross? It's not like, it's definitely not 5 and 20. That was easy. Do you guys agree with me? You can make 5, 20 easy. Can you make 42 become 18 or 18 become 42? No. Can somebody tell me, can you guys see what the biggest number these have in common with each other is? What goes into 42 and 8? 6. I like it. So what's 42? It's 6 times. Somebody's chatting at me. Just
7.
7. Yes. Okay. 6 times 7. And what's 18? 6 times
3.
I like it. So I just rewrote the bottoms, right? I just rewrote the bottoms. But now I can see the first dude. This guy. All right, let me mute that. The first dude. What is he missing on the bottom that the other guy has? What is the first guy missing that the other guy has? What is the first guy missing that the other guy has?
A times
3.
7.
No, the first guy has a times 7. So make sure you're looking at it the right way. So we're going to do the 7 in a minute. The first guy is missing a 3. Does everybody see that? So I'm going to give him a 3. What's the second guy missing that the first guy has? Now you come in with 7. Do you see how the bottoms are the same now? 3 times 6 times 7, 3 times 6 times 7. Because that's the whole idea of let me do this again. I really want you guys to get this. I got some people out there looking at me like I'm crazy. Let me erase some. Oh, scheisse. Let me erase some of this unnecessary business. Oh, shit. Hold on. All right, let me start it. Let me make this. Yeah. All right, here we go. Oh, shoot. Hold on. Let me rebuild this. I can rebuild him. 6 times 7, 6. Is everybody cool with what's up on the screen right now? Oh, just a little crazy. Okay. Everybody cool with what I've done on the screen so far? So the reason I do this is they already both have a 6. And all I want to do is to make the bottoms the same numbers. How do I do that? Well, I just give each one what they're missing relative to the other one. That's going to make them both the same. So this first dude is missing a 3. He does not have a 3 on the bottom. So let me give him a 3. Bam, bam. I got to do the same thing to the top and bottom to make it legal, right? The second dude is missing a 7. All right, let's see what this becomes. What is 3 times 6 times 7?
$126.
126. What is 6 times 3 times 7?
126.
126. So they both have the same denominator. And what's the top of this guy now? He's now 33. What's the top of this guy? He's 35. And now I can combine them. Can you, Jeff? Yes. And then I can reduce it, whatever the hell I got to do. Can I reduce that more? No, I don't think so. Nope. Is that all right? Again, that's just a suggestion. It's just to help you if the fractions get more disgusting. That is one way you can do it. Maybe. Has anyone ever seen that method before? Are you guys? Or do you normally just guess until you get it? I don't know.
Can you give us another example, please?
Sure. Yeah. Sure. Is everybody got what they want up here? I'm gonna clear this whole page so I got some more room to work with.
You can do it in the board, please.
Oh, sure. I can do that. All right. So everybody got what they want? I'm gonna stop sharing. Okay, here we go. Bam. All right, so let me do it up here. I'll do it live. So let's say I've got which got you 11 48 plus let's see. No, let's do. Yeah, okay. Okay. 7/40. Okay, I like it. It should be pretty easy. Do you guys understand? This is kind of gross. This is not easy if you try to do it the normal way, but can somebody tell me what's the biggest number that goes into both of these?
8.
8. 48 is 8 times 6 and 40.
5
8
times.
5. I like it. Now you know exactly what each one is missing. Let me say this real quick. I know some of you guys have kids. If you give them ice cream and one kid gets sprinkles and the other one doesn't, are they going to be happy? No. So this is sort of like they both have ice cream, but this kid got this and this kid got that, and they're looking at each other like, I want that. I want that. So, and I would just eat all the ice cream and say, there, nobody gets it. And that's probably why it's better that I don't have kids. But what is this kid missing that kid has? This kid is missing what?
5.
5. So let me give him a 5 so he'll be quiet. Leave me alone. What is this kid missing that this kid's got?
6.
Now they both have the same denominator, right? This 40 times 6 is 240. So I get 55 2/40ths plus 42 2/40ths makes 97 2/40ths. And I don't think that doesn't look like it'll reduce.
Much better. Thank you.
Sure. Okay. I think that's enough for today. So we basically did section 1, 2. So you could definitely start working on 1, 2 homework. Let me know if you want to hang out, if you got any questions. Otherwise, you are free to go a little bit early. Why not?
I got a couple more questions.
Yeah, what's up?
Oh, it's just a part of the review. I didn't want to like hold anyone back, so I didn't ask them earlier.
No, that's crazy, man. If you got a question, go ahead. What you got?
Well, it's for the review. It was 35 and 36, mostly 36 though, 1336.
Oh yeah, okay. So let me show you a cool way to do this. Oh shoot, I gotta put it on the other screen. Maybe I'll just do it up on the board. So you've got to do well. First off, so if I had to do what you got, 12 divided by 0.06, let's say, right?
Right.
Now, if you do it long division, I'm going to give you a few different options. Do you guys know what to do here with the long division? What do you have to do? When you're dividing by decimal, once, twice, so then you have to do
once, twice.
And now it's simple. 6 goes into 2 and you're done, right?
Okay.
You can actually do that here once, twice, once, twice.
Okay, I'm seeing it.
Because it's really the same thing. You just don't have to change the format it's in. As long, what am I doing to both the top and the bottom? I'm multiplying top and bottom by 100. That's why it's legal. And that's why you always did this when you did long division. Because that's what you're doing.
Okay, I see it.
Cool.
Thank you.
And then one other thing, real quick. If I divide anything by 0.5, all I have to do is multiply by 2. Because then it becomes over 1. So anything divided by 0.5, so 11 divided by 0.5 is 22. I don't even have to think about it. Multiply top and bottom by 2. So if I had something divided by 0.05, I would move the decimal over and then multiply by 2.
Oh.
Do you have to do that? No, but it's neat to know that's available option. So dividing by any point whatever 5 ends up being relatively easy.
Oh, I see it. I definitely see it. Thank you.
You're welcome. All right. How's everybody else? Any other questions?
37.
1337?
Yeah.
Oh, one thing you can do for yourself to make it really obvious what's going on. So if I had a problem like, let's say, negative 18 times, well, it doesn't matter, Jeff, 7/6 m, right? Put this over 1. And then what can I do? What happens here?
Does that multiply those two together? I can't remember.
Well, I'm multiplying these together, but in the process, I'm dividing by 6 and multiplying by 18. So I can reduce these.
Yeah.
And then I get negative 3 times 7 is negative 21 m, and I'm done. So that's how you multiply fractions, you can actually reduce up and down because those are opposite. If I'm multiplying and something's on the bottom, something's on the top, that's actually dividing. So that cancels, I can cancel stuff out.
I think
That's
that
the
was just the last parts of my homework, and so I was not connecting the dots.
Oh, okay. All right.
Thank you.
Yeah. All right. Anything else, guys? You guys okay? I'm going to head out if I don't see any questions. All right. All right. I'll see you guys next week. Have a good weekend.